This lesson is angles. We're going to learn the parts of an angle, how to draw and name an angle. We will also learn the types of angles, do some angle addition, talk about congruent angles and angle bisectors. So that's all in store for this lesson. An angle is a figure formed by two rays with a common endpoint called the vertex. Angles can have points in the interior, in the exterior, or on the angle. So you can see in this angle, the two rays make up the angle, and the endpoint is the vertex. The interior is inside the angle, the exterior is outside the angle, and anywhere on these red rays is on the angle. So for this example, we've got an angle with several points. Points A, B, and C are on the angle. D is in the interior, and E is on the exterior, and B is the vertex. There are three ways to name an angle. You can use 3 points, use 1 point, or use a number. If you're going to use 3 points, the vertex must be the middle letter. This angle here can be called angle ABC or angle CBA. Notice the angle symbol, and notice that the vertex B is the middle letter. If you use 1 point, just use the vertex letter. And you can only use 1 point if that vertex point is the vertex of one and only one angle. If there's any other angle that uses B as the vertex, we can't use one letter. But since here B is the vertex of only this one angle, then we can call this angle B. If B was a vertex of more than one angle, we could not say angle B. Sometimes there's a number near the vertex of the angle in the interior here. If that happens, we can call it by that number. This can be called angle 2. Now make sure that that's not a degree measure. Sometimes if this was really 2 degrees, then and they had a little degree circle there, that would be the degree measure of the angle, not the name of the angle. But that's not a degree measure, it's just the name of the angle. It's angle 2. So we can call it angle 2. So those 3 ways can name an angle. Just remember, you can't use one letter if more than one angle has that vertex point. If that's the case, use the 3-letter name or the number name if they give you a number. So right here, what do we have? K is the vertex of more than one angle. If you think of these as being slices of pizza or slices of pie or something, this angle at the top here is one slice. The angle here is another slice. Or if you put them together to get the whole thing, that's 3 angles that use K. So we cannot call this angle K. No angle K. Because if you say angle K, which one are you talking about? The top slice, the right slice, or the whole thing? There's no way to know. But we do have angle LKM. We do have angle PKM. And then the whole thing is angle LKP. We also have an angle 2. You could call it angle 2 for the top slice. You could call the right-hand slice angle 3. But you wouldn't add those together and call the whole thing angle 5. There is no angle 5 here. That has a name of angle 2, angle 3, but there is no angle 5. So don't use that, and don't use angle K. So types of angles. If an angle has a measure less than 90, it's acute. A cute little angle. That's how you remember it. It's a cute little angle. Less than 90. A right angle has a measure that's exactly 90 degrees, and it will oftentimes have a little box there at the corner, right there at the vertex, saying it's a right angle, 90 degrees. Obtuse angle is greater than 90. Sometimes it'll say between 90 and 180. Obtuse, it's obnoxious, it's obtuse, it's big, big angle there. Or if it's exactly 180, that's a straight angle. It's a straight line, really, but it is an angle that's opened up that far. If you think of this measure going from the left end, wrap it around to the right end, that's a straight angle. So to measure angles, we can measure them just like measuring segments, except in angles we use degrees to measure them. So degrees, think about a circle. How many degrees are in a circle? There's 360 degrees. A semicircle, that's a half circle. That would be half of the 360, which is 180 degrees. A quarter circle, that's a fourth of the circle. That's 90 degrees. And then if you think about it, this seems a little bit strange, but it's true. 1 degree, since the whole circle is 360 degrees, 1 degree is 1/360th of the circle. So it's a little bit weird, but it's true. So if we're measuring angles and adding them together, adding up parts to get a bigger whole, if you want to add angles, we're going to use the notation m of angle 1. We're throwing the m in here. Notice that, the m, the measure of angle 1. When the m is there, you're looking for the measure of it. And that's going to be the degree measure. So what if I added the measure of angle 1 plus the measure of angle 2 here? Let's see. The measure of angle 1 is 36 degrees. I'll just put that in right below here. The measure of angle 2 is 22 degrees. And that gives you a total of 58 degrees. 58 degrees there. And you could also say that since the measure of angle 1 plus the measure of angle 2 equals the measure of the whole thing, and the whole thing is angle ADC. D is the middle letter, it's the vertex. The parts add up to equal the whole thing. Then that means, therefore, and sometimes when you say therefore, you put the 3 dots like that. That symbol means therefore. Therefore, the measure of angle ADC is 58 degrees. So the parts add up to equal the whole thing. Part plus part equals whole thing. And that brings us to the angle addition postulate. That's what we just did. The sum of the two smaller angles will always equal the measure of the larger angle. So in this figure, I'm going to add up the smaller angles to equal the measure of the larger angle. The smaller angles, the one here is angle MRK. The second one is angle KRW. One slice plus another slice equals the whole slice, angle MRW. Notice R is the vertex and R is the middle letter in each of these angles. The vertex has to be the middle angle, or the middle letter, when you name it with 3 points. So if I'm going to do that, I can set up equations and whatnot to find things. So they describe it here K is interior to angle MRW, and then they give some angle measurements. Find the measure of angle MRK. Well, let's draw that. I know I have an angle MRW, so we'll draw that. And then K is in the interior of it. I have angle MRW, K is in the interior of it, and then we'll draw ray RK to make that middle side of the angles. Now we'll label the pieces. Measure of angle MRK is 3x degrees. Measure of angle KRW is x plus 6 degrees. Sometimes you'll see it with parentheses around those and the degree circles. And then the measure of the whole thing, angle MRW, if you want to put this, the whole thing, 90 degrees. By doing that whole arc with the 90 in it, signifies that that's the measure of the whole thing. So let's make the equation and answer the question. Part plus part equals whole thing. The first part, 3x, plus the second part, x plus 6, equals the whole thing, 90. Part plus part equals whole thing. Now let's solve. You got like terms, 3x plus x is 4x. Subtract 6 from each side. Divide by 4. And x is 21. So are we done? Absolutely not. They said find the measure of angle MRK. They didn't say find x. We needed to find x, but x isn't what they asked for. So don't accidentally stop without finishing the question. We need the measure of angle MRK. So the measure of angle MRK, they tell us here, it's 3x. And since x is 21, 3 times x is 3 times 21, and that is 63 degrees. Now I have answered the question. So find x, and then use x. Let me divide that so it's not confusing. Use the x to answer the final question. Sometimes they do ask for x, but sometimes they ask for the measure of something else. Make sure you fully answer the question. Angle bisectors. An angle bisector is a ray in the interior of an angle that splits the angle into two congruent angles. Just like a segment bisector cut a segment in half, an angle bisector cuts an angle in half, and the two halves are the exact same size. So right now we're going to ignore this. So don't pay attention to this. What we have here, since angle 4 is 41 degrees and angle 6 is 41 degrees, then ray UK is an angle bisector. This here is an angle bisector. It cuts it into two congruent halves. Congruent angles, just like congruent segments, were the same shape, same size. Congruent angles have the same measure. Congruent angles are marked with the same number of arcs. And the symbol for congruence, remember, it's the equal sign with the little squiggly on top. Now I need that picture. In this figure, notice angle 3 has one arc, angle 5 has one arc. They're congruent. So you can say that angle 3 is congruent to angle 5. Now, suppose that I had in the same question another set of angles, and I wanted to show that those were also congruent to each other, but not congruent to angle 3 and angle 5. So I would mark those with a double arc. The double arc says these equal each other, their measures equal each other, but they don't equal these. So angle 3 and angle 5 are congruent, and let's say angle 1 and angle 2 are congruent. but angle 1 is not congruent to angle 5. If we had a third pair of angles, we would put 3 arcs in it. A fourth pair, put 4 arcs in it. So let's do one final example here. Draw the diagram and answer the question. If ray ML is the angle bisector of angle PMY and the measure of angle PML is 87 degrees, then find the measure of angle PMY and the measure of angle LMY. Well, the best thing to do here is to draw it. So let's draw it. I know that I have an angle PML that measures 87 degrees, which is almost a right angle. So let's see, almost a right angle. That will be LMP right there. Put some arrows there. And I know that's 87 degrees. I'm probably going to have to move this M down this way. And I know that ray ML was the bisector of a bigger angle, angle PMY. So angle PMY, it's going to come out even farther, really wide there, because that's the big angle. The big angle is being cut in half. You could have drawn the big angle first. Angle PMY is the big one. It's being cut in half, and then you could have drawn ray ML in the middle. That's fine too. I wanted to draw angle PML first since I knew its measure, and I wanted to try to get it drawn appropriately. Well, if this is an angle bisector, then these two angles are congruent. So those are congruent. I'll put 1 arc on each one, and I know that this has a measure of 87 degrees as well. So angle LMY has a measure of 87 degrees. And since angle PMY is the sum of the whole thing, I know that the parts add up to equal the whole thing. Part plus part equals whole thing. 87 plus 87 is 174 degrees. So the parts add up to equal the whole thing. 174 there. Segment addition, it works the same way. Part plus part equals whole thing. Angle addition works the same way. Part plus part equals whole thing.